Shall we do thermodynamics or we can do some other things? Huh? Still, how many lessons left for your board? Off? Yes. Okay. Reduction one more. Only one unit only left. Remaining things are completed. Off exam. For you? So now chemical bonding, okay, no? Shall we do one more day problems? So I will send you the recorded video. Sir will send you. Huh? Yesterday. So these are the process that day we started, right? So tell me, what is isothermal process? When is your board exam? Around February? 11th board exam. Only, yeah. Yes, yes. So next chapter we will go reduction or equilibrium. We will complete the equilibrium and then we will go for the reduction. Okay, first we will complete this, and next week it will take to complete the thermodynamic. The next week we have to work out the problem. Also, we have to move for the equilibrium. Okay. So in the isothermal system, the temperature remains same. Okay. So in this here, the systems are mobile. System and surroundings are mobile. That means if the energy is released here, when the energy is released, then it becomes endothermic. For example, that day we discussed about cracking of fires. That and we discussed, right? Say yes or no. You are not there. Huh? Same. You are taken water. Okay. That water you are freezing, it become solidified. That means ice cubes. The ice cubes become water. So it revert back. So which is endothermic, which is exothermic? What is the meaning of exothermic? What is the meaning of endothermic? Heat is released. When the heat is absorbed means, now you tell me, when you are taking the water, you are freezing, then it become ice cubes. When you are taking the ice cubes, you are keep it in the room temperature, the ice cubes liquefied, right? Then which is exothermic, which is endothermic? It's a melting of water, melting of ice cubes. Exothermic, because it gives out the water. Okay. Endothermic means? How you are saying? Hmm. But we studied in hydrogen bonding. Hydrogen bonding is formed between the two water molecules. That is the reason why the hydrogen molecules become ice. So water become ice. The liquid becomes solid. Now, if you are supplying energy, thermal energy, that is sufficient to break the bond. Now it becomes a liquid. In terms of that, it becomes different. No? What you are saying is wrong. No? You think of. Now, the ice cubes means hydrogen bonding. Water only, the physical state only difference because it is a solid state. So when it forms the solids, okay. So when you are supplying the energy, then the bond will cleave. It become liquid. Then in terms of that, it is exothermic or endothermic. You have to find out. Okay. So when the energy is released, then it become exothermic. Sorry. When the energy is released, it become exothermic. If the energy is absorbed, it become endothermic. So I will show you. So the system, that yellow color shaded is there, no? Put the figure mark. When the yellow color shade is no, that is system. Whatever surrounding that, that will be surrounding. So when the system, okay, it's absorbing heat from the surrounding. Outside the heat enters. Then it become endothermic. So the ice cubes taken the energy from the room temperature, then it become liquid. Then what is that? Endothermic. Surrounding. So the Q value is plus because it takes the energy. Okay. Q is temperature. What amount of temperature difference that is. Then exothermic means when the system given out the heat. So when you are putting the acid to the water, what will happen? That entire thing will become hot. So when the acid is diluted, the reaction is exothermic. ஒன்றும் இல்லை, வீட்டில் வந்துட்டு பூரி சுடுறாங்கன்னு வச்சுக்கோங்க. அந்த பாத்திரத்தில் if you are pouring water, what will happen? நல்லா ஆயில் ஹீட் ஆயிருக்கு. Heat on oil, you are pouring water, what will happen? So yeah, anyone can answer. So in your house, the oil is heated oil. When they are cooking, no. So for making puri something, if you are pouring water to the boiled oil, what will happen? Why it happen? Then what is that? அதனால so when it become hot, okay, all the molecules are get boiled, no. When you're putting the water, the oil is oxidized water into hydrogen gas. Once it forms the hydrogen gas, it catch fire. That is it. Same way, When you're pouring water to the concentrated acid, that's why what you have to do, you have to keep the water in the beaker, you have to add acid slowly, then it get diluted. Otherwise, it's very become difficult. Clear? So that's the reason why that is exothermic. So when you are diluting your acid, exothermic. When you are diluting your base, it's exothermic. Suppose it's absorbing heat and feels cool, means what it tells. So it's taking energy from the outside. It's not dissipating their energy to the surrounding. That is, when it absorbs heat, it's endothermic. When release heat, it becomes exothermic. So that's why this is called exothermic and endothermic process. So what we are doing in the isothermal process, how much of work done we are measuring. That means here same temperature. So temperature will not differ. So same temperature is equal to constant, isn't it? Temperature going to be, it will not going to change. That's why they say dq dt becomes 0. dt means difference in the temperature, because temperature is constant or same. So when you are having the gas, so gas equation, what is the gas equation? What is the gas equation for the ideal gas equation? PV is equal to nRT. So P is the pressure, V is the volume, R is the gas constant, T is the temperature, N is the number of moles, right? So if you are calculating maximum work done after the correction, W work maximum is equal to minus 2.3 nRT log V2 by V1 or minus 2.303 RT, so nRT, log P1 by P2. So this is the maximum work done we can calculate. Okay. So V1 is the initial volume of gas, V2 is the final volume of gas, P1 is the initial pressure, P2 is the final pressure. So the maximum temperature change becomes 0. So N moles of ideal gas for the work maximum is equal to minus 2.3 nRT log P2 by V1, or otherwise nRT log P1 by P2. Either volume changes or pressure changes that we can calculate in terms of work. So this PV is equal to other. Okay. Now we are going for the adiabatic process. Adiabatic process means it is like isolated system. The system is isolated. What is isolated system? It cannot exchange mass or energy. Neither mass nor energy. That is isolated. So you are taking a flask. Flask is isolated because when you are pouring the hot water, after 2 hours it becomes hot water. When you are pouring 90 degree, it becomes 90 degree. It won't change because it was separated from the surroundings. Okay. So this is called isolator. So this process, temperature will not, it can increase or decrease, but it will not exchange. So the heat dq is equal to 0. Temperature will not, we will not change, no. So in this process, temperature can increase or decrease, but change in the heat will not be observed. That is known as adiabatic process. And then isobaric process. Isobaric process means they are considering constant pressure. So the change in the pressure is equal to 0. dP is equal to 0. So what are the example for the adiabatic process? Vaporization of water. Vaporization of water. Or boil. So what happens when you are heating the water boiling point become equal to your atmosphere pressure, then water gets boils. So that time the pressure is constant. When you are heating, the temperature is changing. Correct? Water heat now, the temperature change of the volume, it may change. Okay, but the pressure it won't change because the same pressure only we are doing. Now dump open vessel heat the water become vapors. ஓகேவா? அப்ப என்ன ஆகுது? டெம்பரேச்சர் சேஞ்ச் ஆகுது, பட் ப்ரெஷர் வந்து சேஞ்ச் ஆகுது இல்லை. ஸோ பார் மீன்ஸ் pressure. So same pressure, isobaric. And then isochoric. Isochoric means the volume is constant. The dV is equal to 0. And then cyclic process. What is the meaning of cyclic? You are started that day. அது இருக்கா காமிச்சோமா? Starting ending இல்ல. So okay, I will show you. When your cyclic process means, so the process one we can change. For example, you are in the second floor, you can run to the ground floor through the steps. Suppose if you have ramp, you can walk through the ramp, or if you have the elevator lift, you can travel through the lift. So wherever you are starting one point and ending with one point. So if you are going and standing in the first floor, it's an intermediate, correct? So neither in the second floor or in the ground floor, but you are in the first floor, that is the intermediate. So how it was changing, that you are finding means that is known as cyclic process. So if you want to calculate the efficiency of engine, or if you want to calculate the reaction energy, it involves the cyclic process. Okay. And reversible process means when you are see in a chemical reaction, we are calculating bond energy. Bond energy only, it tells whether the reaction is happening or not. Suppose when you are taken the reactant, it convert to product. So what are the things happen? Bond formation and bond breaking. So these are the two things will happen. When the bond breaking means you have to supply the energy. So if you are supplying more than your bond energy, that bond will be clean. During the bond formation, energy released. Energy is released. Now, when the energy released, which is less than your supplied energy. Otherwise, when the reactant forming the product energy is more than the reactant, that reaction is irreversible. It won't take place. Suppose when this is the reactant, this is product. When you have the potential, sorry, I will draw. When you have the potential energy, so potential energy, reaction coordinate. So when the reactant and the product, so this is the energy of your reactant, this is the energy of your product. Okay, so the product energy is more, reaction energy is less, means it is irreversible. Suppose same type of graph, the reactant is more, product is less. So this is the product energy, this is the reactant energy, then it is called reversible. So that means what? When you have small amount of energy, that is sufficient to break the product form. Okay, wow. So this is called reversible and irreversible process. This is called reversible and irreversible process. I told you that say itself, internal energy is depends upon the our reactant. So it has their own internal energy. So the internal energy generally based upon the rotation, translation, vibration, potential energy, nuclear energy, Coulombic attraction or repulsion. So all those things combined give the internal energy. So now we are concentrated. Today we are concentrated work and heat. What is work? What is heat? So when you are taking a system, the system has their energy. It may increase or decrease. Correct? So the system has the energy. It may increase or decrease. Generally, we can calculate that increase and decrease energy in the two forms. One is work, another one is heat. in the thermodynamics. Okay, so work means what? Motion. Okay, when you have the atom, when it have the motion, or when it combined with one more atom, what is the force of attraction? Or suppose if we are taken two reactor and heating, we are supplying energy, then how much work done by the system or done on the system, that we are calculating. That's what we are mentioning here as a work. Okay, so work is a mode of energy transfer. It's a system with surrounding or surrounding to system. From system to surrounding polam, surrounding to system polam. So that we are mentioning as a work. So work we can say force into displacement. Force into displacement. So two types of work in thermodynamics. One is electrical work and another one is mechanical work. So electrical work, and mechanical work. So when you are seeing the electrical work, so when the reaction taking place means there is a electromotive force, each and every ion, it gives their energy. That energy you can convert into electrical energy also. Okay, when the solution conducting electricity means, so you can have the potential difference. That potential difference generally they call it as potential difference will be there, and how the electron is circulated in how the reaction converted into electricity, it can be measured in terms of electromotive force, that is EMF. So that EMF, it gives the electrical work, it gives EMF into electromotive force into quantity of electricity. How much volt it gives produced. Okay, quantity of electricity. In terms of volts. So இவ்வளவு amount of voltage, இவ்வளவு amount of volt வந்து produce பண்ணுது. Okay, எவ்வளவு potential difference இருக்குங்கறத பார்த்து சொல்றது EMF. And the second one, mechanical work. So the mechanical work gives the pressure volume work. When you have a system with a change in the volume and you are externally applying the pressure, what will happen? That we are measuring as your mechanical work. Okay, ஒண்ணுமே இல்ல, நார்மலா so நம்ம மீட் வீட்ல வாங்கிட்டு வராங்க. When they are cooking, no, you can cook it in the normal pot itself, but especially what they are given, they are using cooker, isn't it? வீட்ல cooker யூஸ் பண்றாங்களா இல்லையா? What is the purpose of cooker? That also have different size, 3 liter, 5 liter, 7 liter, 2 liters, 8 liter, 10 liters, isn't it? They are having, no, boy kadayila ponamna mutton biryani vandu they cook it in the dabra இல்லையா? Whereas in the home we are where we are cooking. So what is the relationship? That relationship, why we are having different size? இருக்கும். நல்லா யோசிச்சு பாருங்க. விசில் அடிக்கும் போது வெளில உள்ள இருந்து என்ன வருது? Pressure get released. அப்ப என்ன அர்த்தம்? When you are taken and you are so you are having different volume. That 3 liter, 5 liter, 10 liters. எல்லாத்துக்குமே ஓகேவா? இப்போ once you are cooking, it gives the உள்ள என்ன நடக்குது? There is a reaction between whatever you are putting ingredient. So that ingredient la enna agum? The volume get expanded. The liquid transferred into gas. When the gas coming, no, it has to have some space to accommodate. When the space is more than that, it's not enough. So it producing so much gas, it has to leak out. Adha enna pandrom? When you are filling the water and keep it in the fridge, complete full fill பண்ணி close பண்ணி வைங்க. அப்ப என்ன ஆகும் கேட்டீங்கன்னா, இது break ஆகும். Because water உள்ள இருக்கிற vapors வந்து அந்த pressure kum gas the liquid kum gas kum idella equilibrium. So it has to maintain. That's the reason why they are giving the space. Sila liquid pathina below space la liquid irukum, below the space. Why they are having that much pressure now? Because that much vapor pressure it has. And the vapor pressure increases, it has to release. Otherwise, it will break. Appo same way, when you are cooking, appo enna agum ulla heat panna keela vera temperature ni rise pandra. Volume same ah vechittu temperature rise pandra. Appo pressure change avuma agada. That's what happens with the pressure. So immediately it release the pressure. Once the pressure release another enna aidudha, it comes to the normal aidudha. Appo enna artham ulla irukka gas la veliya eduthu. So இதே போல தான் அந்த லிக்விட வெளிய தள்ளுது. அத தான் இங்க நம்ம படிக்கணும். இதுதான் மெக்கானிக்கல் வொர்க்னு சொல்றோம். இதுதான் ஹீட் கால்குலேட் பண்றதுன்னு சொல்றோம். புரியுதா உங்களுக்கு? நம்ம வீட்ல என்ன நடக்குதோ அதான் தெர்மோடைனமிக். நம்ம கிச்சன் தான் தெர்மோடைனமிக். அதுல நடக்கிறது எல்லாமே தெர்மோடைனமிக். ஈச் அண்ட் எவ்ரிதிங் திங்க் பண்ணி பாத்தீங்கன்னா ஓஹோ இது this is what happened. If now you got an idea, no? Now you can relate, no? So you don't pressure means this much amount of pressure you have to supply. Don't think that when you are having and applying, if you are measuring with the manometer, it shows how much pressure it is there. Okay, namakke pressure irukku solrom illaya. Why we are telling like that? What? So is it clear? So we have to study about when the gas. So gas la நம்ம என்ன சொல்றோம்? Real gas, ideal gas சொல்றோம். So what will happen that we have to study in terms of the chemical reactions. Okay, you can apply external pressure or the reaction itself can create the pressure. When you have the closed system or isolated system, you are changing something. Autoclave னு சொல்றாங்க. Autoclave is nothing but a pressure cooker. உள்ள என்ன பண்றீங்க? உள்ள இருக்கிற வேக்யூம், ஐ மீன் கேஸ் எல்லாத்தையும் ரெடி பண்ணி உள்ள வந்து வேக்யூம் கொடுக்குறீங்க. வேக்யூம் கொடுக்கும்போது என்ன ஆகும்னா உள்ள இருக்க கேஸ்லாம் வெளியே போயிடும். உள்ள வந்து ஒரு எம்டி வாய்ட்ஸ் கிரியேட் பண்ணுவீங்க. உள்ள லிக்விட் இருக்கும், அதுக்கு மேல யூ கிரியேட் எம்டி வாய்ட், then you are doing the reaction. At that pressure the reaction will happen. இப்போ ஒண்ணுமே இல்ல, ஒரு இது இருக்கு, இப்படி வந்து க்ளோஸ் ஆயிருக்கு. சரியா? இந்த லிட் வந்து நகரும். ஓகே, கீழே இருந்து மேல வரைக்கும் நகரும். ஓகே, வித் பிஸ்டன் வச்சுக்கோங்களேன். இட் மூவபிள். இங்க வந்து வாட்டர் இருக்கு. ஓகே, so we are going to put a sodium metal. What metal? Sodium metal. When the sodium metal, if you put to the water, it form sodium oxide plus hydrogen. This hydrogen catch fire. So this sodium oxide, when you are dipping with the water, it gives NaOH, sodium hydroxide. But it catch fire, no? When it form the gas, what will happen? It can expand. Upon how much of sodium get reacted? So this will be lifted to this portion. So from here to here it was lifted. That we can measure or not? That's what they are measuring and they are saying this is the one there. If you are applying external pressure or internal pressure created there. So it is work done by the system or done on the system. The concept is clear? Is it okay? Those who are in the online, is it okay, ma'am? Yes, sir. கூட ஒரு பொண்ணு வருமே, அந்த பொண்ணு பேர் என்ன? ஸ்ரீநிதி. காணும். இங்க ஒரு கேள்வி பண்ணுறீங்களா? நேற்றுக்கு வந்து கல்யாணம், நேற்று முந்தா நாள் அவசரம். Nobody is there. Okay. So now we are going to see about the heat. What is heat? So we are saying as a just work in the form of energy. So energy can be exchanged between the system and surrounding. It's no doubt about it. Okay. So if it is expanded or contraction of gas taking place means, so the heat will involve definitely. So that we are measuring and saying this amount of energy. So say similarly, so difference between them, what we are measuring, That is, we are call it as heat transfer. Okay. So you have system and surrounding. Either the pressure is, you can calculate for the gas, you can calculate the pressure. Or if you are taking the reaction, when it is exothermic or endothermic, you are calculating the heat. Correct? So other than the heat and okay, wow. So the temperature difference between system and surrounding only we are call it as heat difference. Okay. So they will represent by the letters Q. So Q usually measured in calories. In the SI unit, it become joule. Heat oda unit the calorie normal, but SI unit joule. So what is calorie? 1 calorie abina. So the quantity of heat required to raise the temperature of 1 degree of 1 gram of water. So 1 gram of water temperature, if you want to raise 1 degree centigrade, first you are measuring what is the temperature of water. Then you are raising, you are heating for some time. Then what is the difference between the temperature that you have to measure? So 1 gram of water, you have to raise 1 degree of temperature, that gives 1 calorie. Okay. So that calorie is the normal centimeter, gram, seconds unit, CGS unit. The SI unit, what is the unit of heat? That will become joules. So what is the difference between heat and work? You tell me what is the difference between heat and work? When you supply the heat to the system, what will happen? For the gas, system is gas medium. Okay. You are supplying heat, what will happen? Pressure cooker it get what is the term you can use? Huh? You are it get one more term. When the heat is supplied to a gas is your system. Okay, what will happen? It expand, isn't it? It will expand. So when you are starting, give the temperature. So the work will be done on the system. So immediately it will expand their energy. Okay. So this is so work is organized form of energy. The heat is random form of energy. It's a random form. Form of energy. So the work you can calculate anywhere. Okay. When the heat means so organized form, this much amount of energy is given. Temperature is. So this is the basic difference between heat and work. Okay. Now we are jumping to the first law of thermodynamics. With the pressure volume work, I told you, no? So, according to the first law of thermodynamics, the energy can neither create nor destroy, but you can convert one form of energy into another form. This is the first law of thermodynamics. Okay. So now we have to. So energy is observed means by the system means plus Q is the symbol. Work done on the system means plus W. So what will happen? Automatically the internal energy of the system will increases. So internal energy depends upon the system. Okay. So internal energy can vary with the, what are the things? Force of attraction, nuclear energy, Coulombic force of attraction, potential energy, and then rotational energy, vibrational energy, translation energy, electronic energy. So all will combine as the internal energy. Suppose if the energy is absorbed by the system, absorbed means what? Endothermic. It's absorbed by the system. Automatically, work will done on the system. Okay, so that system absorbing means the temperature is plus Q. Work done on the system is W. So look this mathematical form we are calculating. Okay, so energy is absorbed by a system. That means plus Q. Therefore, work is done on the system. Then it becomes W. So automatically internal energy. What is the term used for internal energy? U. Okay, it also increases. So E1 is the initial internal energy. Initial internal energy. E2 is the final internal energy. So what is the difference? So you know that internal energy is equal to Q plus W, right? Internal energy is equal to Q plus W. Then only it will automatically increase. Suppose if the Q is reduced or W is reduced means the internal energy also reduced. That will be work done by the system. Okay. So now you tell me this is what process, endothermic or exothermic? Energy is absorbed. Then what is the process? It's an endothermic process. Look now. So internal energy is equal to Q. You won't. It will not vary, but the work Q. What we are saying E2 minus E1 that become Q plus W. So what is that E2 minus E1? It become delta E or delta U. Anything you can put. Delta U is equal to Q plus W. This is the first law of thermodynamics. Now, this mathematical first law, you have to apply for the isothermic process, isochoric process, adiabatic process. We'll apply one by one. First one, isothermal. So now you tell me for isothermal means what is constant? What is constant? So temperature is constant. So energy of the system is equal to what we are given? Q plus W. Q means what? Heat given to the system plus work done on the system. That is Q plus W. Now you tell me you have the Q plus W. Here, temperature is 0. The temperature is constant. So automatically delta E is 0. Why? Temperature is because temperature is constant. So now Q plus W is equal to 0. Then Q is equal to, so according to isothermal. And then it's going isochoric. Isochoric means what? Volume is constant. Right? So when the volume is constant, work is. So system does not do any work. Volume is 0, no? Volume is constant, no? The volume will not change, then system does not work. So automatically W become 0. Then what you will get? You will get delta E or delta U is equal to what you will get? Q. So you will put small v. It indicates volume is constant. So what is that? The heat is given to the system at constant volume, change the internal energy. Heat given to the system at constant volume, it can change the internal energy of the system because the volume is constant. So next process, adiabatic. Adiabatic means what? neither transfer nor neither exchange. Okay, it's like isolated. So adiabatic. Then temperature become Q is equal to 0 because it does not transfer no system to surrounding to system. So Q is equal to 0. Then delta E become. So what is the meaning? The work done the system equal to change in the internal energy. Here for the isochoric process, work done the system, the internal energy of system is dependent upon the heat energy. Isothermal process, amount of heat is equal to the work done or not, done by system or done on the system. So now isobaric. We have one more, no? Isobaric. Isobaric means constant pressure, right? So here what we are saying, pressure is constant. Okay. So PV is equal to nRT. This is the gas equation. Okay. So that PV we are taken. That we are considering as a work done. Work done. Work we are taken force into volume. So pressure into volume. Now the pressure is constant. The volume will it can change, no? So P into delta V. Now delta E is equal to Q plus W. This is what we have seen in the first form of mathematical equation. Now you know that W is minus. Okay, because done on the system, the work done by the system. So W is minus negative because work done by the system. Done on the system means you look here plus W. Okay. Q plus W. Done by the system. That's why W is negative. So W is equal to minus P delta V. So you put it in the equation. Delta E is equal to Q minus P delta V. If gas expanded in vacuum, work done is 0. Okay. Then P is equal to 0. About delta E become Q minus delta V. So this is the mathematical equation. We will see the application of this first law in the next class. Okay. Then we have to calculate. We have to calculate the first equation. W is equal to 2.303, where we have written the heat energy. Work maximum is equal to minus 2.303 nRT log V2 by V1 or P2 by V1. Suppose if you are getting minus value, then you have to say work done by the system. If it is positive value, you have to say work done on the system. Okay, that we have to calculate. So sign of W is important. So when the sign of W is negative, done by the system. That means W is equal to minus P delta V. Suppose we are taken W as positive, one done on the system. That only we are going to calculate next class. Then here they are introducing one more concept, enthalpy. Because here many bond energy only in one. Bond energy means what? Potential energy. When the two atoms bring it together, at certain point the energy gets reduced. It becomes stable. That energy only we are telling at bond energy. That potential energy that's drastically reduced. So we discuss in the valence bond theory. Now that bond energy, when the two reactant reacting means, so this bond will have some energy, this bond will have some energy. It has to cleave and it has to form new one. For example, sodium hydroxide you have taken, hydrogen chloride you have taken. Sodium and hydroxide having one bond, hydrogen chlorine having one bond. Now you have to cleave these two bonds. This give rise to sodium chloride and water. So the new bond has to form. If the energy is released, it becomes exothermic. Now the energy is absorbed, it becomes endothermic. That's what we have to show. Is it okay? For that reason, they have given the enthalpy. So enthalpy, how we can define? No, you are in the same way. So you started one place and you are going to the other place. What way you are going? So in between you are standing means you can change your place also. So I am going from the second floor to first floor through the steps. And the first floor to ground floor, I am going to the elevator. So now the path has been changed. Path is very important. Where you started, where you ended. What is the energy of the first one? What is the energy of the final one? What is the difference between these two? It gives rise to the enthalpy. Now the enthalpy and your energy, you are connecting. So H is equal to E plus PV getting. So application of the first law, it gives rise to the enthalpy. The drawback of the first law, so the advancement of the first law, it gives to the second law, that is entropy. Okay. Then the third law gives free energy. In these three factors, which decide whether the reaction is feasible or not at room temperature. For example, when the rain is fall from top to bottom, nothing is going from bottom to top. No. When the falls, if you are going, the water is fallen from top to bottom. It's not go from bottom to top. It's a spontaneous one. So if you want to measure the spontaneity of the reaction, you should know about the enthalpy, entropy, free energy. If you know these three values, these three things, you can describe whether the reaction will turn or not. Okay, this is what we are going to do. Okay, we'll meet in the next class. Is it clear? Any doubt? You would you have to discuss. In between, we should have some interaction. Pressure cooker pressure expand thermodynamic weight like kitchen but we are not thinking that. If you are connecting, it will become easy. Okay, we'll meet in the next class. I try to finish in the next class. Okay, this portion.